Hello everyone, welcome to Let's Program with Santier, and today we're going to continue working on the timeline program. I spent a little bit of time thinking about how some of the further algorithms need to work, but I noticed something really important, which is this right here needs to have node dot this. That's why my thing didn't work previously, because I forgot to actually make it resolve the rightmost node candidate recurse collapse thingy. So yeah, hopefully that will fix that particular bug. So I was looking at this and kind of thinking about, okay, what do I actually need this to do? How do I need this to function? And what I decided is that once this is the case, what we actually just need to do right now is search for rightmost off of searcher. And then we can return. Okay, so the reason for this is because, and I can get rid of all of this. Yes, I think so, yeah. So the reason for this, why we can do this, is because this functionality is logically identical to this functionality right up here, what we're doing right here. Now, I do want to go ahead and get rid of that little bit of code and this little bit of code. So the idea here is that we're going back, okay, and I don't need candidate in here anymore either, is we're going back and we're finding the node that we need to begin searching from, right? Or the node where we kind of will be beginning our search. So this one says, okay, if there is a split timeline in front of us, okay, this part checks for a split timeline in front of us. If there isn't one, then, well, in that case, we will move on. But if there is one, then we need to go and we need to search through that split timeline for the rightmost node candidates. Okay, so right here, what we have is we need to get to the first node that's below our line. And then we can just search for candidates from there, right? This is going to do the same process of looking for new timelines to come off of. If it's not, it needs to the longest line, that sort of thing. It's the exact same process that needs to happen here. Now, I do want to change this function a little bit because I want to add a timeline event node. I don't know what to call this thing. We're going to go ahead and it's the timeline parent over here. So maybe I'll just keep that name. Sure, we'll just call this timeline parent again, just to be consistent. So what this is going to do then is like I said, a lot of the functionality needs to be the same. So I need to figure out how to actually set that up, but I want line length equal candidate dot width. Size dot width. Man, I'm doing that a lot. Okay. Enough that I'm beginning to think, do I need to add just a dot width to those? I'm going to need that to be able to track lines. So there's a couple of things that make something a candidate. Let's see. Now I need to remember what's going on here. Okay. So I want to get rid of this note. So the way that I'm going to do that is I'm going to say right here, okay, this thing, while child however does not equal null, what I actually want to do is, like, that's kind of important. Start.next. So what I actually want to do here is if child haver tracker dot next is equal to null. Now I actually want to put it right here. Do a thing. So if the next is equal to null, and this means we're Okay, let me think about what that means. I just want to put break here. So the reason why I want to do that is this is still going to be on the same line, right? So this break is going to break this while loop. It's going to break us out of that loop. We want to preserve node information. Okay. Nation as we need to identify the last node in the line. So if we're still in here, that means this should have the same spot as the next, right? So what I want to do is come down here and say, if child haver tracker dot next is does not equal start. No. Okay, so if child haver tracker does not equal null. No, that doesn't make sense just because it shouldn't equal null. Well, whatever. We can check if it does not equal null. So I need to, let me just pseudocode this out. If the child haver tracker is is on the same line as start. Okay, so if child haver tracker has a null next and is on the same line as start, or child haver tracker isn't on the same line as start, but the previous is on the same line and is not start, then I'm gonna just make this capital F. Child haver tracker is a candidate. Start. Let's see if the child haver tracker has a null next and is on the same line as start and isn't start, or the child haver tracker isn't on the same line as start, but the previous is on the same line as non-start. Child haver tracker slash its previous is a candidate. So the idea here is that if we get to the end of a line, and this can just be a void, can't it? Because this, I don't care about the return anymore. That means I'll have a return here, but what this means is timeline parents dot right most node candidates dot add candidate. This is if candidate does not equal null, then we want to add it. We don't want to add it if it's null. Okay. I guess it's not likely to be null, but okay. So where was I? I was down here in the pseudocode. So the idea is if this has gotten to the end of the line, we want the last node on the line because it's a possible candidate. It's not guaranteed, but it's possible if we're on a line. That's just a fact. So what I need to do here, the other thing actually that I need to do here is candidate equals start, and line length needs to equal candidate dot size dot width. Okay, so if child haver tracker dot next is equal to null, and child haver tracker dot win dot raw value is equal to start dot win dot raw value, and child haver tracker does not equal start, and then I need timeline parent dot rightmost node candidates dot add child haver tracker. So this is the case of if child haver tracker is at the end of a line, is at the end of the line start is part of and isn't start, then add it. This will happen if we break out of the above while loop. I'm just going to do that. Okay, so that's the first case. So that's the first sort of initial if, right? So if the next is null and child_haver_tracker.win.raw value is equal to the same, basically if it's on the same line as start, but it isn't start, then we want to add it because it's a possible candidate. The next thing that we want to do is if child_haver_tracker, so this is going to be .next is not equal null, right? Because this is the other case. And child_haver_tracker.win.raw value does not equal start.win.raw value. And child_haver_tracker.previous does not equal start. In this case, let's see, do I care about the next being null or not? This should be previous. Actually, I should just go ahead and change this to previous does not equal null. So if child_haver_tracker.previous does not equal null, because if the next is if the same node gets put in here twice, it's not a problem, because one of them will resolve the first one, and it won't be a problem. So I'm not too worried about doubling up. So in this case, if it's not the start and the not start.win.raw value, so this needs to be an equals, not a not. So if the previous is, oh yeah, okay, I see what I was doing here. If this is not on the same line as start, and okay, so this is massive. So I'm going to actually break this up a little bit because this is massive. Because I also want to add child_haver_tracker.previous .win.raw value is equal to start.win.raw value, and child_haver_previous does not equal start. So if the start exists, or if the previous exists, and this is not on the same line as start, and previous is on the same line as start, and previous is not equal start, then timeline parent.rightmost node candidates.add child_haver_tracker.previous. Okay, so this is the second case. If the child_haver_tracker has gone onto the next line and the previous line ended with a node other than start, which is a node with a child, then that line ending node is a candidate. Okay, so I'm going to go ahead and leave this up here because why not? So the idea here is I need to capture the end of lines. And this right here should do the end of lines when I have a child in that line, right? When I have a split timeline in the line. This should capture that. And that kind of gets this information here. So if we don't have a child, then there's a couple of things that we need to do. So if there isn't a child, if start dot, let's see, if candidate, okay, so if there is a child, that whole thing gets kind of reset. I need to think about the logic for a second here. Okay, so it's either going to be, I need to look at some of my charts here. So if there is a child on the line, then we're only going to need to care about either that line or any of its possible children down that timeline, which is what we're going through with the candidate here. So we've reset to the timeline that we're checking. Previous ones will influence this one, so it should be good. So what I need to do here is if candidate dot win dot raw value is equal to start dot win dot raw value. Okay, so the issue that I have to be very careful of right here is that if these guys are on the same line, I need to make sure this is not tracking start twice. Does that make sense? So I actually think I do want to start candidate. Let's see, is there a reason why I should not start? Okay, here's my, I'm going to do this so I can find the start of the function. The rightmost node from a given node and assigns any found candidates to the timeline parent. The node to start searching for candidates from the node to receive candidates. Okay, so that'll help me find the top of the function. It's just I was scrolling past it. I think I actually want to start this at null, unless there's a reason why I shouldn't, and I don't think there is. So if I start this at null, let's see, with this, yeah, okay. Candidate should go ahead and equal null again. That's actually important, I think. I'm gonna go ahead and set the line length to be 0 because candidate is null and that'll make things explode. So the reason why I'm doing that is because this will add candidates already. But what I care about here is if candidate win, so obviously there's the problem of candidate size, but I'm not caring about candidate size anymore. I'm caring about line length. So if candidate.win.raw value is equal to start.win.raw value, so if candidate candidate does not equal null, and candidate.win, I mean, technically, I guess I could have left candidate start and just checked candidate does not equal start. But if candidate does not equal null, and candidate.win.raw value is equal to that raw value, line length plus equals, oh. Okay, this is interesting. So that actually relies on, okay, so I'm going to actually change this to not equal start. And instead of doing this, I'm going to just go ahead and start and line length equals candidate dot win dot width, or no, not win, size dot width. Actually, do I even want to do it that way? I could actually start the line length at 0, because then when it's equal to itself, it will update, if that makes sense. Yeah, whatever, I'm going to leave it that way. Start and candidate dot size dot width. Okay. I'm just kind of like on the fly having to figure out how I want to do this. Okay, so if the candidate.win.raw value is equal to start.win.raw value, line length needs to add start.size.width, and candidate needs to equal start. Okay. So the idea here is that if the start node is on the same line as the previous candidate, no, that's okay. So this is actually really wrong. Okay, how do I need to handle this? What am I tracking? I'm tracking. Okay, candidate should not be involved in most of this tracking. So what I actually need to do here is if start.previous does not equal null and start.previous.win is .raw value is equal start.win.raw value, then okay, so I need two line lengths, which is int line length and cur line length equals 0. So this is candidate line length, and this is current line length. So current line length is going to equal 0. So this one right here is candidate line length equals 0, and this equals 0. That equals 0 because we're on a new line, right? We've gone into a new area. So kind of the logic, just kind of run through what I'm thinking here, is this is going to record the line length of however long this candidate line is. So we're going to be checking lines for their overall width. This is going to check if we are making a line right now, how wide is it? This should actually just be start.size.width. And what we're going to do is we're going to be comparing when we make a new line, or when start is on a new line, we're going to be comparing the line length. So this is going to be cur line length plus equals that, candidate plus equals start. The reason why candidate is plus equaling start, or rather, no, candidate should not equal start. So what's going on here is if start is iterating on a line, then the current line length is growing. And this should be start dot size dot width, I think. There might be some bugs in here, but I think the overall base logic idea is sound. So if start doesn't have previous. Okay, so what we're doing is we're saying, okay, we're going to be kind of increasing in size. And then okay, so if start is on a line, then we need to count the line's length. So else, okay, so I need to actually take this out of this if, and put an if start.previous does not equal null. So this can be on a line. If start.previous is equal to null, then we're at the start of a line already, so we don't care, if that makes sense. Like, we've already got the information. So if start does not have a previous, that means that our candidate is equal to start because we haven't moved on to the next one yet. And we either start there with a line. So if we start a new timeline search here with start.child, or start.child is where start's going to be now. And so start shouldn't have a previous, and the candidate's set to start. So we don't actually care about the else state. So what we care about is, because it's already been set to be the candidate. So if that is the candidate, then that'll be the candidate. tautologically. Let's see. I do need to advance to the next node. This right here can be deleted. Okay. So then we need to count the line's length. If they're not on the same line, then what I need to do is if current line length is greater than, okay, I need to make sure that this doesn't lose stuff. Candidate line length. So this is going to probably need to be copied and pasted down here, because if start runs out, we can get to kind of like the last node, and that could be the node that we want, if that makes sense. So, how do I want to handle this? Sorry, I'm cracking my knuckles all over the place, and it's probably making hideous noise. I could make a lagger that kind of is just like the last one. Start does not equal null. That should be fine. We need to process start. We don't care about. So I guess I should add a lagger equals null. And then what we do is this advance to the next node, and this else, because that works there. Yeah. Okay, so start.child. Yeah. Okay, so right here we need to go lagger equals null. Right here we need to go lagger equals start, start equals next. What the lagger does is it's recording what the previous node was. So that when we get down here, we can check if current line length is greater than candidate line length, then candidate equals lagger. So that's going to be the last node found, right? This is important to do, because if we don't do this, then what can happen is we can be incrementing, and this could be the case where the current line length has been made longer than the candidate line length, but by the time when we finish going through here, right, start could be then null, and then we would pop out and not check that. So it's actually a common problem that can show up in programming quite often, where you have a, for lack of a better term, where you have a some sort of loop that's checking something, but the last instance of the thing that you're checking doesn't get checked, if that makes sense, because you're forgetting to check it because the loop ends before you would check it in the loop, and if you don't add a thing to check after the loop, it just kind of like gets forgotten. So it's not uncommon, which is why I was kind of aware to look for the problem. Drink break. Water. Okay, so if the current line length is greater than the candidate line length, so first of all, what we need to remember is that we're on a new line. So in this case, what we need to do is we need to update the candidate to lagger, because remember, lagger would have been the last thing of the previous line. The last item on the previous line is the new candidate. Okay. Because the only way for, let's see, the only way for this to be the case is if we've moved far enough that the candidate is not equal start. Because right now the candidate line length and the current line length are actually both being set to the same value in this case right here. And that's going to be the same thing right here, where I'm doing the exact same set of code. Because candidate and start are the same node. So this is only going to happen if we've been able to advance. Just making sure that like I can't assign a null to it. So candidate equals lagger, because that's the end of the previous line. So that's the one that we care about. And then candidate line length needs to equal current line length. So we need to update that. And then let's see. Current line length equals start dot size dot width. So new line, restart the length. So what this is going to do is when we come through here again, we're going to say if it's on the same line, we're just going to keep adding the width onto it, right? But if it's on a new line, then we'll check this again before we move on to the next one. But this is what I'm saying. We're doing this check before we update the value. So it could be that this value, we could then end, and that value might be wider, in which case we need to check it here. So hopefully that all makes sense, and hopefully this code works. I think that it should. We'll find out. We will find out. Okay, so that should locate me my candidates. The candidate collapse function up here should now collapse the nodes. Remember that this checks to make sure it can collapse them first. We're going to have like some amount of like extraneous, oh, the store has already been collapsed, so I guess we just didn't do anything with this function call, but it's fine. We just need to make sure we go over everything and collapse everything, because there might be stuff that like won't get collapsed from like higher up stuff or whatever. It's just important to be thorough. It doesn't mind to throw a few cycles at that. So I think what I want to do now is test this. So build succeeded. So let's go ahead and let it load. Man, these last few episodes have been kind of long, haven't they? This one's already at the sort of half an hour mark that I wanted to hit, but I can't just like end it on a cliffhanger, can I? Need to make sure there's a teaser for next time. Okay, so let's add a standard event, a split timeline, and standard event. Let's see. I don't know. What do I want to test? Let's just make sure that this stuff is working in the first place. So let's put this at 50. Let's go over here. Let's add an event and put this at I don't know, 60. And just make sure that this is, yeah, okay. So that's being pushed over. Okay, so what happens if I go ahead and move this to 20? Not 200, just 20, please. Sorry about the bings. It's just a side effect of how that thing works, and I wish I could get it to stop. Okay, so that's getting moved over for our unnamed event. So that's cool beans. Like, cool beans is one of those phrases, you know. Let's see. It looks like, am I having? Yeah. Okay. So that's just taking the length of the main timeline, not any other timelines when I'm doing that. So that might be something to look at as well. It may be that some of the processing that I was doing, I'm not doing anymore, so it's like not properly chaining all the way down, as it were. Because that zoom should be more like that, right? But that's getting moved over, so that's good. So the next thing that I want to do is I want to add a couple more events at 20. Actually, I can just bump this guy to 20. Does that put it? Okay. Wait. Down, then up. There we go. Getting the crazy sorting working right. Making this have a very long name for testing purposes. Okay, so that now has a very long name for testing purposes. I want to add a split timeline at 0. Call this one Bob. Call this one Jerry. And call this one Felix the cat, because I guess. And Bob here needs a standard event. I'm just going to put this at the good old 100, just so that way it hangs down low like dog ears. Okay. Sweet. So what we're seeing right now is normally this would be unnamed event down here that Bob would be looking at under the old algorithm. But now it's looking at make this have a very long name for testing purposes. And that's pushing Bob over the way that it's supposed to be pushing Bob over. So now hangs down low like dog ears is you can see where that is. Okay, that's really cool. So there's probably some other cases that I need to test. So let's just go ahead and make another split timeline after Bob. Split timeline and call it after Bob. Let's give it an event. Let's put this event at like 36 and call it before Bob, just to be confusing. Okay, so that's getting into my descriptor information, but we can see that that's being pushed over by hangs down low like dog ears, which is good, because that's where it should be. Okay, so there's probably a few more tests that I need to run just to make sure I'm hitting all of my like corner cases. But I don't know. Right now I'm feeling fairly satisfied with this. Let's see, this corner case. So, sure, let's go ahead and do some more tests off of the main timeline here. I want to add a standard event at 60. I'm going to add a couple standard events at 60. Okay. Oh, that's got some formatting errors. That's unfortunate, but okay. Easy enough to fix. And I'm just going to make this a longer name. Felix the cat. Make this a longer name, I guess. And then I'm going to call this Parson Brown is a snowman. And I'm not sure about that. Okay. So now we can see that this is both each individually is shorter, but then Felix the cat, make this a long name, I guess. But together they're longer and they're appropriately moving over Jerry, the Jerry timeline, which is moving over Bob and after Bob and all that stuff. So it looks like there's probably some more rigorous tests that I can do with like multiple timelines at the same time and tomfoolery with that, but I'm actually fairly happy with where this is at. So I feel like I've actually maybe finally conquered this hideous formatting problem, and there's some other stuff that I can begin looking at next time. So I thank you for joining me. I'm going to sit here and celebrate my ridiculous, impossible to fit on the screen, stretched out timeline with Parson Brown and all this jazz. And next time maybe I can examine the possibility of making more of a proper scroll or proper zoom. I can do this where it, scales it around the point that I have the mouse, but I can't make the width adjust because the text is always a specific size. I guess I could make it adjust text size, but I kind of want to see if I can do some other stuff. So, and then I also want to finish up some of the stuff with saving being going away. But I think that's going to go ahead and wrap it up for me for today. So take care, everyone. Bye-bye.